This assessment asks us to give the product of treating an alkene with MCP-BA and H3O+. Now, specifically here, we're using the E-alkene, so we need to show the stereospecificity inherent in this reaction. The reaction is going to start in step 1. We're going to make an epoxide, and that epoxide can form on either the front or the back of the alkene. Let's show it adding from the front, knowing that half the time it will add from the back. Spoiler alert, we're going to get a racemic mixture here. We'll talk about that at the end. And so we can draw the product epoxide like this. I'm going to show the hydrogen. We're going to have the epoxide be on the front face of the molecule, and now we can put in our 2 methyl groups as going back. So this would be the product of step 1 plus its enantiomer. So we'll talk about that at the end. Next, we're going to add H3O+, and I'm not going to show a full mechanism here, but when we take this epoxide and treat it with acid, one of the first things that's going to happen is we're going to protonate here, and then a molecule of water will add to this carbon. Now, why does it add to this carbon? This carbon is tertiary, and if we had drawn out the structure of the benzene ring, resonance stabilized. So remember, water is going to open at the side that would be the most stable carbocation. Well, when it does that, it pushes these electrons up. In the next step, that proton is going to fall off. But what's important here is that this carbon-oxygen bond here is on the front of the molecule, so when the water adds, it's going to add from the back side. And so the product we get in this step, in this reaction, the answer to this problem is going to be that we're going to let's keep the phenyl and the hydrogen the same. We're going to have the hydroxyl group at this carbon going back. Our methyl group will have been pushed forward. The other side, nothing will change. The OH is still on top. The methyl group is still in back. So we would end up with this product that shows these 2 hydroxyl groups on opposite sides of the carbon framework. What's the other product we get in this reaction? We get the enantiomer. And how does the enantiomer form? When the epoxide forms on the back face, then water attacks on the front, we would get this as the other product. We'll keep the phenyl and the hydrogen in their same plane of the page. Now the methyl group would be going back, the hydroxyl group here coming forward. This hydroxyl group is back, and this methyl is coming forward. These 2 molecules being enantiomers of each other, we end up with a 50-50 racemic mixture of the 2.